in every in chemistry, it is very important to give a name to the compounds. See, like why we are having a name. Some people they are having James or like say Thomas or like Alfred. So these are some of the common names, right? Right? Why people are giving name? Because in order to identify that particular person from their name, right? So the same way in chemistry, the compounds usually they get a name. See, let's see the criteria or like let's see how the compounds are getting some names. See, for some of the compounds, like it is having some common names. It will be there. For example, ammonia. So this is actually NH3. This is actually ammonia. And hydrogen chloride, hydrochloric hydrogen chloride. So this is HCl, and maybe water. So H2O. So these are actually common names. It is there. There is no other way. You just have to by heart it. But of course, apart from that, there are certain elements, certain compounds which get a common name, which get a name. For instance, if it is a metal, if that compound containing a metal and non-metal, for instance, sodium, sodium NaCl. Okay. So in that case, you have to write a sodium and chloride. So this is a non-metal. Non-metal, it is supposed to come the second. So sodium, the name should be sodium chloride. And now let it be another one, MgS2. So this is actually magnesium, which is the non-metal in this. Non-metal is a sulfur. So magnesium sulfate. So magnesium is the metal. So magnesium sulfate. And maybe now AlF3. So this is aluminium fluoride. So aluminium is the metal. Fluorine is the non-metal. So it is supposed to be, the name should be aluminium fluoride. Now if the compound it is made with more than both are non-metals, let it be hydrogen. See, let it be both are non-metal. For example, hydrogen chloride. So in that case, you have to write the name of hydrogen first, and the next element it should be second. So it is hydrogen chloride. Next one is, see, let it be CO2. So this is carbon dioxide. The one which is having the lower, if it is otherwise, the one which is having the lower group number, it is supposed to write first. For example, carbon, it is in the 4th group. Oxygen, it is in the 16th group, right? Or you can say, carbon, it is in the 14th group, and oxygen, it is in the 16th group. Okay. Now, that is how the elements are giving, that is how the compounds are giving names. Every compound, it is having a name as well as formula, and it is easy to comprehend its name. I mean, it's a formula from the structure of the compounds. For example, you can see the compound, sodium chloride. It is, see, you can see now. Yeah, it is having very giant structure. So, but if you closely observe that, you can see that the Na plus, it is bonded to Cl minus, which it is in turn is bonded to Cl minus, and Na plus, it is bonded to Cl minus, and it is Na plus, so it is Cl minus, and so on. Okay. So this way, the ratio is every Na plus, it is bonded to one Cl minus. Okay. So this is how it is coming. Now what you can understand, so its a formula is going to be NaCl. Okay. On the other hand, and if you are checking a single molecule, for example water, so one oxygen, it is bind to two hydrogen atoms with a V-shaped molecule. So its a formula is going to be H2O. And if you are same way, if you are taking a single molecule, one carbon, it is bound to 4 hydrogen atoms. Okay, so its a formula is going to be CH4. And in the same way, same like sodium chloride, which is having a giant structure, you can check into silicon dioxide. So silicon dioxide, it is having a very network type of structure. Okay, very network type of structure, and every silicon atom. So you can see the structure of silicon dioxide now. So every silicon atom, it is bind to two oxygen atoms. Okay, if you check the ratio, so its formula is going to be silicon dioxide. Okay, so you can just check it up how many number of atoms are binding to each other. From that, it is easy for you to comprehend how many number of like what is its formula and how many number of atoms are binding to each other. Okay. You doesn't need to remember about it's a formula so much if you know the valency of each element. For example, the elements, each element in a particular group, it will follow a particular valency. For example, group 1. See, for example, group 1. Yeah, okay. Okay. Group 1, it is supposed to have a valency 1. Okay, because you can know from, let it be fluorine. Fluorine is one of the elements. Sodium, fluorine, lithium, sodium, potassium, rubidium, not fluorine, cesium. So these elements are all having only one electron in the outermost shell. So the valency is nothing but how many electrons it is supposed to lose in a reaction, or how many electrons it is supposed to gain in a reaction, or if it is a covalent bond, how many electrons it is sharing in a reaction. Okay, for example, like a sodium, it is, or potassium, 19 is the atomic number. So 2, 8, 8, 1, 10, 18, 19. So this is supposed to lose only one electron from the outermost shell. So sodium is going to have valency 1, right? So group 2 in the same way, okay, group 2. So in the same way, it is going to have 2 electron in the outermost shell. Okay, 2 electron in the outermost shell. And group 3 in the same way, group 3. So it is going to have 3 electrons in the outermost shell. It is going to have 3 electrons in the outermost shell. And group 4, for example, carbon. Group 4, it is nothing but carbon. See, carbon, it is 2, 6. Carbon, it is actually 6. 2, 4. So 4 is the, how many number of electrons? 4 electrons are there in the outermost shell, right? So if it is forming a reaction, for example, let it be CH4. Okay. So CH4. So this is going to share, so 1 electron from carbon, and see, 1 electron from hydrogen. Okay, so this is the structure of CH4. So the valency of a group 4 elements are 4 because it can share 4 electrons in the outermost shell. Okay, and group 5 electrons, group 5. Okay, group 5. So you can know P is the phosphorus is one of the element. Other elements are nitrogen, phosphorus, arsenic, antimony, and bismuth. So if I write from phosphorus with the electronic configuration 15, so it is going to have 2, so I will write in here 2, 8, 5. So in order to attain octet, if it want to get octet, okay, then it is either it is supposed to gain 3 electrons, or it is supposed to lose this 5 electrons, which is easy. Obviously, to gain 3 electrons are the easiest task. So this group 3, 5 elements, it is going to have 3 is the valency normally. And same way for group 6. Group 6. So 6 electron will be in the outermost shell. For example, normally the elements are oxygen, sulfur, selenium, arsenic, tellurium, and polonium. These are the elements. So oxygen with the electronic configuration 16. So it is going to have 2, 8. Not 16. I mean 8 is the atomic number. So 2, 6. So it can gain 2 electron, so that this will become 2, 8. So that the valency, I mean like a valency of a group 16, group 6 elements are 2. Okay, and group 7 elements, or on the other hand, group 7 elements, so it is going to have 1 electron is in the outermost shell. Okay, and transition, see how to write the formula using valencies. For example, if you just know the valency of a particular atom, it is very easy to write the formula. For example, like a sodium chloride. See, sodium it is having +1 is the valency, chlorine it is having the -1 is the valency. So you just reverse it. You just write its elemental, atomic symbol here. So you can put 1 here. This one supposed to come here. Chlorine, this one supposed to come here. So this is going to be, since both sides it is equal, so we can write NaCl. Now you take sodium sulfide. Sodium sulfide. Sodium is Na, sulfide is S2 minus +1. So this way. So Na. So this 2 is supposed to come below sodium, sulfur. Okay, this 1 here it is 1. So it is Na2S. Now you take a magnesium chloride. So you take let it be Mg. Okay, magnesium chloride. So MgCl. So +2 1. So here, so MgCl twice. So this 2 supposed to come below chlorine. Just diagonal form. Now let it be aluminium oxide. So how will be the formula of aluminium oxide? So let it be aluminium oxide. So Al. Oh, so +3 -2. So you can just reverse it. So Al. So this 2 is supposed to come below aluminium. Oxygen here 3. So Al2O3. So this is how the formula of the compounds it is being given. Okay.